Okay, number 79. Let's read through the problem. In number 79, two automobiles are 150 kilometers apart and traveling towards each other. One automobile is moving at 60 kilometers per hour and the other is moving at 40 kilometers per hour. In how many hours will they meet? Okay, first of all, I want you to notice how similar this is to the buggy problem on the lab that we did. We have a certain distance apart, we have two vehicles going at different speeds, and we send them towards each other. Remember that our definition for velocity, for average velocity, and both of these have a consistent velocity, so we can use the average velocity formula, is change in x over change in time. I want to figure out the time, and the reason I'm wanting to solve for time is they're going to take the same amount of time to get towards each other. So I'm going to rearrange this problem and say that time is distance over velocity. And so for car A, if I take time is distance over velocity, I get that time is distance, which actually I'm going to call that distance d. And car A's velocity is 60 kilometers per hour. For car B, I'm going to use that same equation, and car B, its distance, well, this time its distance, if car A has a distance of d, then car B has a distance of 150 minus d, and its velocity is 40 kilometers per hour. Now, what I said a minute ago is that this time is equal to this time. The same amount of time it takes for car A to travel and meet is the same amount of time it takes for car B to travel and meet. And so we can now set these two equal to each other. So I'm just going to set up a proportion and I'm going to solve it. Okay, so I'm going to get 40d. When I go this way, I'm going to distribute and I get 9,000 minus 60d. I'm going to solve this equation and I get 90 kilometers. Now let me talk about units for just a second. Typically we use meters per second. That's our SI for velocity, or velocity is meters per second. We have kilometers per hour. We don't need to change our units. And the reason we don't need to is because this question is asking about hours and everything's in kilometers per hour. And so we don't need to change units. We can stick with kilometers per hour. So I get that the distance is 90 kilometers. However, the question wasn't asking about distance. It was asking about time. And so if I have, it doesn't matter which car I take, but I've got car A going at 60 kilometers per hour, and it goes for 90 kilometers. If I need to solve for time, I'm going to use this to solve for time. And so I divide those and I get for my time 1.5. My units, let me talk about units for just a minute. My kilometers cancel. I have hours in the denominator. When I bring those up, they become in the numerator. So this is 1.5 hours. So the time it takes them to hit each other would be 1.5 hours. That is answer A. Okay, let's take a look at the first free response problem. The vertical position of an elevator as a function of time is shown above. So we have a position time graph. On the grid below, graph the velocity of the elevator as a function of time. So what we need to do is we need to look at the velocity of each section. Notice what's going on. This is a position time. So as we're going up here, this slope is going to be meters per second. That's going to be our speed. It's going to have a positive speed. Then here our slope is 0. It's stopped because it's in the same position, 14 meters above. And then it comes back down, and its slope once again is going to be the speed. Notice it's a little bit curved here and a little bit curved here. So I'm going to cut off my slope right here. The slope of this section is 12 meters over 8 seconds. And so I can reduce that. 12 meters over 8 seconds is 1.5 meters per second. So the speed in this section is 1.5 meters per second. The speed in this top portion, of course, is 0 meters per second. It's not going anywhere, it's flat. Then the last section is, it has a negative velocity, it's going down. It is down 12. and it takes 5 seconds for it to do that. So I go ahead and divide that out, and I get negative 2.4 meters per second in this section of the graph. Now, the pieces that are curved, I'm going to talk about those in just a minute. Let's take a look at how to graph this. One thing is we want to use a ruler. Make sure you're using a ruler to graph it, just so that you have nice straight lines, and the grader, which is me right now, but will be the AP graders later, those graders can see exactly what you're doing. Okay, so on my graph, I'm going to have one section here at 1.5 meters per second. Okay, right here is 1.5 meters per second. And I've used a ruler and made a nice straight line. Now, ignore this curved part, this sloped part for just a minute, because the flat part on this graph goes from 10 to 18. So from 10 to 18, I have a flat line. The speed there is 0, so it's right there at the 0. Then the last part is a negative 2.4 meters per second, so I went down to negative 2.4 meters per second. Notice I didn't go to negative 2.5. I was careful to stay above that line just so the grader knows that I know it's not negative 2.5, it's negative 2.4. Also notice it stops at 25 seconds, and so this graph also stops at 25 seconds. Okay, the curved parts here and here, we talked about that a little bit when we were doing this a couple weeks ago. We need to connect those. If I just had a straight up and down line, it wouldn't be a function. You'd be like in several places at once. It just wouldn't make any sense. So I'm just going to connect these sections with a slanted line. And that's just connecting the sections, because obviously the elevator doesn't just stop instantaneously. It does have some slowing down and stopping time. So that's what's going on here. Okay, the next question, part B, says calculate the average acceleration from the period from 8 seconds to 10 seconds. Remember that our formula for average acceleration is change in velocity over change in time. So the velocity, the final velocity, is negative 2.4 meters per second. And the question is asking from time 8 to time 10. So we're talking about this section right here. What is the average acceleration during that time period? Okay, so the final velocity is 0 meters per second. The initial velocity is 1.5 meters per second. And the time goes from 8 to 10, or in other words, 2 seconds. So if I do this calculation, I get a negative 1.5 meters per second over 2 seconds. So that's going to give me a negative 0.75 meters per second squared. So that's the answer to B, part 1 is 0.75 meters per second squared. It is negative because it is slowing down. All right, the last part of this question says on the box below that represents the elevator, draw a vector to represent the direction of this average acceleration. That is this average acceleration. Now, keep in mind this elevator is not in free fall. If it was in free fall, the acceleration would be negative 9.8 meters per second squared. But thankfully, it's not in free fall. It is moving with the assistance of cables. And so this average acceleration, it is downward because it's negative. This is the average acceleration. When we haven't focused a lot on these, but when we do these box diagrams like this, we typically don't need numbers in here. So let's just leave it as that. Okay, let's turn over to the next question. Okay, a student throws the ball straight upward. So throws the ball straight up. A friend times how long it takes the ball to reach its max height. The student predicts, faster things take less time. If I throw the ball faster, it will reach its highest point in less time. What, if anything, is wrong with this statement? If something is wrong, identify it and explain how to correct it. If the statement is correct, explain why. The first part of what that person says is kind of true. Faster things take less time. That's true, but it's not going to be true in this case. If I throw the ball faster, it will reach its highest point in less time. Not necessarily, because if you throw the ball faster, what's going to happen? I think it's going to go higher. And if it goes higher, it's going to take longer, right? Okay, So we're going to explain that, but we're going to take some steps to explain that. Okay, here's what I'm going to say first. The more initial velocity the ball has, the higher it will go. And so I'm going to use this formula to prove my point. Final velocity at the top of the throw is 0. Initial velocity is what we're kind of talking about here. I do know the acceleration is -10, and I'm looking at how high it goes, which I'm calling delta x. I could call it delta y if I wanted to. If I go through and solve this, I'm going to subtract my v naught to the second and put it over here. But when I subtract it, I get a negative over here. So I'm going to get initial velocity squared is equal to 20 times the change in height. So in other words, the faster the initial velocity, the higher the ball will go. For example, if the initial velocity is multiplied by 3, then the height will be multiplied by 9. So what I'm saying is if we had a 3 times initial velocity and we squared that, it would give us 9 times the height. And so the faster we throw the ball, the higher it's going to go. Okay, next I'm going to take a different equation because what I want to prove now is this was dealing with height, but they were talking about, it would be less time, it would go faster. So I kind of want to incorporate time here and see what's going to happen. So I'm going to use this equation. I'm using the initial velocity to be the top of the max height. Okay, it's the top of the parabola. So if that is 0, then I have this equation. And I can plug in a -10, that's gravity. And so I get that the change in height is -5 times time squared. Now I do want to solve for t and take the square root. I just want to focus on this portion of it right here. What this is saying is time is equal to the square root of the distance divided by 5. And this is approximately 5 because gravity is -10. A minute ago I said if the initial velocity is multiplied by 3, then the height will be multiplied by 9. So let's plug in a 9 times that height because it's going 9 times as high, but yet I have to take the square root, so it turns out that the time is 3 times as great. In other words, the faster you throw the ball, the higher it will go. And the higher it will go, the longer it will take to reach that maximum height. So the person in the beginning was actually not correct. So let me talk a little bit about the problem as a whole. There is always a problem on the AP test called a paragraph length response. And for a paragraph length response, it's just that. They're asking you to write a paragraph. Notice in my answer here, I had some sentences and some words. I also had some equations and some numbers from time to time. So basically, I'm kind of combining a couple of sentences of reasoning, logic, what have you, with some justification for that. And so I'm using those equations to justify what I'm saying in words, but I can't cut out the words. I have to have the sentences. It's a paragraph length response. The graders are looking for a full paragraph. So this is not a full paragraph. It's kind of a couple of bullet points, but actually it's got some significant information here. So tomorrow's test will not have a paragraph length response. However, the AP test will. And so I'm just trying to get us started thinking about how do we approach a paragraph length response. Now, tomorrow's test will have things like this, these solving equations, and if this is increased by 3, this is increased by 9. Or if this is increased by 9, then this time is only going up by 3, things like that. So the concepts here are definitely covered in tomorrow's test. But the paragraph, we do not have to do that for tomorrow. All right, I hope that this video helped you to understand a little bit more about the packet.